Okay, good day everyone. So today we're going to talk about finding slope. I'm going to go back to the previous page on here so we can talk about what slope is. I'm going to fill this out. Ways we can think of slope. Slope can be thought of as rise. Ooh, that's not working. Hold on, give this a moment. Of course, if it was working, I wouldn't be making a video. And because I'm making a video, it's not working the way we want it to. Because Murphy. All right, slope can be thought of as rise. So write the word rise over run. Okay? And just so we have more to look at here, I'm going to, let's see, make some color here. Blue, we'll make that our rise. We'll say rise, which means up and down. And then rise over run, and run is left and right. Rise over run. I don't even think that's very good, but doesn't look too good. Okay, slope can be thought of as rise over run. We can also think of it as the change in y, because that's how we get our rise, by changing y, the y variable. And that's over the change in x. So we can think of slope as change in y over change in x. And we often represent slope with the variable n. Okay? So we've got this formula, the slope formula. M stands for slope, and that's this right here. We got two y coordinates. We're going to take the difference of the y coordinates, and we're going to put that over the difference of the x coordinates. So we'll be given 2 points. I always say it's good to label one point as x1, y1, and label the other point as x2, y2. Okay? And then all we have to do to find slope is to do that little bit of arithmetic. So once again, slope is the change in y over change in x. It's the rise and run. Now, one thing you're going to probably see me using this year is you're going to see me write the slope is, I'll put a little triangle, y, whoops. And I'm going to put that over a little triangle, and then x. Now, the triangle represents the Greek letter delta. Okay, so I'm going to say m, which is slope. Slope is delta y over delta x. Delta just means change in. It's a math symbol for change in. So it's a change in y over change in x. Okay. So I want to find the slope between these 2 points. So what I'm going to do first is I'm going to label these points with x1, y1, and x2, y2. So this is my first point. So this is my first x. So I'm going to label this. This is x1, and this is y1. This right here is my second x coordinate. So this is x2. This is my second y coordinate. So this is y2. So to find slope, I'm going to write that formula again. M equals y2 minus y1 over x2 minus x1. And now I'm going to plug those values in. it's going to be something minus something over something minus something else. Okay? Now, what goes right here is the y2. The y2 is right here. It's the number 7. So I'm going to put a 7 right here. 7 minus y1. y1 is a 3. So 7 minus 3. And on the bottom, I start with x sub 2, which is this right here. It's that negative 4. X sub 2 minus x sub 1. And x sub 1 is a negative 2. So this is my slope. I got to calculate this to get my slope. At this point, you can use a calculator and stick that in the calculator, or you can do the calculation yourself. If I do this myself, I know that 7 minus 3 is 4. I know that anytime I subtract a negative, that double negative right there, that's the same thing as adding. So I'm going to change this to plus. This just becomes a great big fat plus, the two negatives. So negative 4 plus 2 is the same thing as 2 minus 4. Well, that gives me a negative 2. So my slope so far is 4 divided by negative 2. If I divide 4 by negative 2, to just carry on, I end up with the m equals, a positive divided by negative is negative, and 4 divided by 2 is just 2. So in this case, my slope ends up being a nice integer number, just negative 2. Now it's still rise over, Ron, so I can think of this as a negative 2 over 1. But I've calculated the slope. Example 4, this next example. Same thing I'm going to do here as I did last time. I'm going to label, this is my x sub 1 and my x sub 2, or my y sub 1. This is x1, y1. That's all those points are, that those numbers are. X sub 1, y sub 1 are the x and y coordinates of your first point. X sub 2 and y sub 2, those are your x and y coordinates of your second point. So I've got them labeled. I know that when it calls for x sub 1, I'm going to put a 6. When it says y1, I'm going to put a 2. Anywhere it says x2, I'm going to put a 5. Anywhere it says y2, I'm going to put a negative 3. So I'm going to use the formula. M equals, and I know it's y sub 2 minus y1 over x2 minus x1. And then I'm going to just plug those values in there. It's going to be something minus something over something minus something else. All right, in the top left, I've got y2. y2 is right here. It's that negative 3. So it's going to be negative 3 minus, and then y1. y1 is a 2. So a negative 3 minus 2 on top. And on the bottom, it's x2 minus x1. So x2 goes right here, which is just 5. And then x1, in this case, which goes right here, is a 6. Now you might hear me say x1 or x sub 1, x2, x sub 2. Really what that means is like x sub 1 means x with a subscript of 1, x with a subscript of 2 for x sub 2. Or I can just say x1, y1, x2, y2. They all mean the same thing. All right, so let's do the arithmetic here. a negative 3 minus 2. They're both negative, so I combine them. So a negative 3 and a negative 2. 3 plus 2 is 5. They're both negative, so it's going to be a negative 5 on the top. On the bottom, 5 minus 6. Now these are different. It's positive and a negative. So it's the same thing as taking a difference. This is the same thing as 5 plus a negative 6. When the signs are different, you take your difference. The difference of 6 and 5 is 1. But the bigger number is the negative. The 6 has the negative in front of it, so it's going to be negative 1. Okay, now this one simplifies real easily. Negative 5 divided by negative 1. The negatives just cancel each other out, and then 5 over 1 is merely just 5. So the slope is 5. Let's see how that would look on the calculator. So if I go to desmos.com, scientific, yeah, that's what I want. And I'm going to put in my fraction. So I'll put in fraction. And I wish I were looking at that paper right now. Where was it? That's not it. There it is. So I'm going to put in a negative 3 minus 2 on top and a 5 minus 6 on the bottom. Negative 3 minus 2. I'll just X out of those. Negative 3 minus 2 on top and 5 minus 6 on the bottom. So on top, get back there on top, negative 3 minus 2. Negative 3 minus 2. And then I just arrow down to the bottom. And then I put 5 minus 6. And we can see all of that just equals 5. So if you just know where to plug the numbers in, the calculator will give you the simplified slope. All right, I'll do 2 more. I'm going to make these a little bit more fast, okay? I know I'm just going to write it out real quick. The slope formula, m equals y2 minus y1 over x2 minus x1. Okay, my y2 is the 1. y1 is 3, so 1 minus 3 over the x2 is a negative 7. And the y1 is a negative 7. Okay. Now let's see what happens if I put this in my calculator. 1 minus 3 over a negative 7 minus a negative 7. One minus 3. Scroll down, and then I'm going to do negative 7 minus a negative 7. And I get this crazy thing. It says undefined. Undefined. It doesn't simplify to any number. Let's see why. Well, we know what 1 minus 3 is, or maybe we don't. If I do 1 minus 3, that gives me a negative 2. But if I look at the bottom, it's the negative 7 minus a negative 7. So negative 7 minus a negative 7. And notice what that gives me. It gives me 0. So my rise over run, change in y over change in x, equals a negative 2 over 0. So really what I've got here, these 2 points, if I plotted those points, maybe I should plot those points just so we can see what's going on here. I'm going to plot negative 7, 3 and negative 7, 1. I'm going to do that in Desmos graphing calculator. That's not what I wanted. I didn't want the scientific calculator. That's okay. I'm going to just desmos.com/calculator is the graphing calculator. And to plot points, I just simply put those points in there. So I'm going to plot the point negative 7, 3 and negative 7, 1. So I'm going to plot -7, 3. There it is, right there. Now I'm going to plot -7, 1. Check this out. From the last unit, we learned something. I've got 2 points. There's also this vertical line right here which crosses through those 2 points. There's a vertical line where x equals a -7. Check it out. Here's this point right here. -7, 1. And here's this point right here, -7, 3. This vertical line goes through both of those points. That's not a function, right? It's not a function. We've got the same input has 2 outputs, so that's no good. It's undefined. There's no slope there, okay? So that's a special case. When you have points where one's on top of another, you end up with a vertical line, and the vertical line is always going to be undefined. There is no number there. There's a special rule in algebra. The special rule is thou shalt not divide by 0. It's like the first commandment of the 10 commandments of math. Thou shalt not divide by 0. Anytime we end up with something like this where we have a 0 on the bottom when we're calculating slope, our answer is undefined. All right, we'll do another one here real quick. We'll do this one real fast. This time I'm not even going to write the formula out. Okay. I know it's going to be something over something over something over something. I know I start out on top with y2, so that's going to be a 2. And I subtract y1, which that's also a 2. I'm already starting to see something that's going to happen over here. On the bottom, I start with x2, which is a 3. And then I subtract x1, which is a 1. Now, when I do this final arithmetic, 2 minus 2 is 0. 3 minus 1 is 2. Notice the difference here. This was a -2 over 0, which is undefined. This ends up being 0 over 2. Well, let's think about it. 0 divided by 2. Dividing by 2 is cutting something in half. Okay? If you cut 0 in half, what have you got? You still got 0. Okay? Or if I had no cookies, how could I split them between 2 people? It's fair. They both get the same thing. They both get 0. So this one, the slope, just equals 0. And let's see what that line would look like if I plotted those 2 points. What would that line look like? So we'll see what a slope of 0 looks like. So I've got the point 1, 2 and the point 3, 2. So I'm going to graph those 2. 1, 2, and 3, 2. 1, 2. And I'm going to go ahead and label that one. And I'm going to have to move here so we can, there it is. I can see it right here. And then I'm going to graph 3, 2. I'm going to tell it to label. Now, both of these points lie on a line where the y-coordinate is 2. So I'm going to graph that just so we can see it. Y equals 2. Check it out. These 2 points lie on a horizontal line. So a vertical line has a slope which is undefined, and a horizontal line has a slope of 0. This is why I have slope 0, because the slope is a measure of the steepness. So basically, as something gets steeper and steeper and steeper, its slope increases. It increases, it increases, it increases, and increases. Well, how high can you say this goes? It goes to infinity. It's rising infinitely, but you know what? There's no run, so it can't be defined. It's just an undefined thing. It's not functional. Besides, infinity is not a number. It's something you approach, you never get to. So we can't say where it is. We can't give it a value. It's undefinable. So that's all I've got about getting slope from 2 points. And that is all.